Hello there, and welcome to the Bedtime Science. Tonight, we turn our gaze upward, not to the distant stars, but to the quiet companion that has followed us for billions of years, the moon. For as long as humans have looked at the sky, the moon has been our mirror, our clock, our storyteller. Its light has guided travelers, shaped tides, and inspired myths in every culture on Earth. But beyond poetry lies science, and the moon holds more secrets than its pale glow suggests. So, let your breathing slow, let your thoughts drift, and let's wander together through 40 gentle facts about the moon, each one a quiet window into its mysteries. The moon is about 4.5 billion years old, born in the very earliest chapters of our solar system's history. To imagine this age is to step outside the boundaries of ordinary time. It means the moon was already shining in the sky before the first forests grew on Earth, before the first fish swam in ancient seas, even before the continents had taken shape. Every time we look up at it, we are looking into a mirror older than any mountain or ocean. Scientists believe the moon came into existence only a short while after Earth itself was formed, perhaps just 50 to 100 million years later. In cosmic terms, this is almost immediate, like the aftershock of a single event. The leading explanation is known as the giant impact hypothesis. According to this idea, Earth had only just finished forming from clouds of dust and gas when a wandering protoplanet, roughly the size of Mars, collided with it. This world has been given a name, Theia. The impact would have been unimaginable, an explosion of energy powerful enough to melt rock and reshape planets. When Theia struck Earth, much of its outer layers were torn apart and hurled into space. The debris circled Earth in a glowing ring of molten stone and dust. Over time, gravity gathered these fragments together, slowly forming a new body, round, heavy, and steady. The moon. This violent beginning is written in the chemistry of lunar rocks. Samples brought back by the Apollo missions show that the minerals of the moon are strikingly similar to those on Earth, especially in their isotopes of oxygen. It is as though the moon is made of Earth's skin, a piece of us that was thrown outward and now orbits quietly above, always bound, never free. Once it formed, the moon began its long dance with Earth. At first, it was much closer, perhaps only 0 to 30 kilometers away, compared to today's 384, 0. In those early days, it would have loomed enormous in the sky, more than 10 times larger than we see it now. Its gravity pulled fiercely on Earth's young oceans, creating towering tides that crashed across the continents. The days were shorter then, too, as Earth spun faster under the pull of the newborn moon. Over billions of years, this interaction slowed Earth's rotation and pushed the moon farther and farther away to the more distant orbit we see today. The moon's great age also means it carries scars that Earth has long since healed. Our planet has winds, rains, and moving tectonic plates that erase old marks. But the moon has no air, no water, no plate tectonics. Its surface is a still photograph of ancient history. Every crater, every ridge, every plain of dark lava is a record of time stretching back billions of years. In some ways, the moon is more honest than Earth. It remembers everything. To think of the moon as 4.5 billion years old is to realize it has seen nearly the entire lifespan of the solar system. It was there when the first asteroids drifted, when the giant planets settled into place, when comets carried water to the inner worlds. It has watched Earth grow from a molten sphere into a blue-green planet, alive with oceans, forests, and people who look up at it in wonder. And tonight, when you glance at the moon, you are seeing the same companion that shone down on the first creatures crawling from the sea, on the dinosaurs, on the earliest humans who carved its faces into stone. It has never left us. It has been here the entire time. 4.5 billion years of silent watching, steady orbiting, and patient light. The moon is not just old, it is eternal in our story. The moon did not appear gently, like a stone settling into still water. Its birth was an act of violence, a colossal collision written into the earliest history of Earth. Scientists call this idea the giant impact hypothesis, and it remains the most widely accepted explanation of how our moon came to be. About 4.5 billion years ago, the solar system was young and chaotic. Planets had only just taken shape from swirls of gas and dust, and countless leftover bodies, large and small, wandered unpredictably through space. Among these was a world about the size of Mars. Astronomers have given it a name, Theia. Theia's path eventually crossed Earth's, and what followed was one of the most dramatic events our planet has ever known. When Theia struck, the energy released was beyond imagination. Rock and metal melted instantly. Vast portions of Earth's outer layers were torn away. For a brief time, Earth itself may have been surrounded by a glowing halo of molten stone, a ring of fire encircling our world. Out of this chaos, something extraordinary happened. Gravity began to take hold of the scattered debris. Slowly, over thousands of years, the fragments gathered together. They clumped, collided, and merged into a single growing body. What had been destruction gave birth to creation. The moon was born. Evidence for this violent origin is hidden in the chemistry of lunar rocks. When astronauts returned from the Apollo missions, scientists discovered something remarkable. The moon's rocks have almost the exact same isotopic fingerprints as Earth's mantle. They are not foreign material. They are us. This suggests that the moon was forged from Earth's own body, mixed with pieces of Theia, fused into a new world that still circles us today. At first, the newborn moon was far closer than it is now. It may have hung just 20 kilometers above Earth's surface, so close it would have appeared huge in the sky, filling entire horizons. Its gravitational pull was fierce, raising tides hundreds of meters high that washed violently across the young Earth's surface. Our days were shorter too, lasting only 5 or 6 hours, as Earth spun rapidly under the tug of its new companion. Over billions of years, the relationship between Earth and the moon began to soften. Tidal forces transferred energy, slowing Earth's rotation and pushing the moon gradually farther away. Even now, the moon continues to drift from us by about 3.8 centimeters each year. That gentle separation is a quiet echo of its explosive beginning. The idea of such a collision is difficult to picture. A world striking another world, both torn apart and remade. And yet, without this impact, Earth might be unrecognizable. The moon stabilizes Earth's tilt, calming its climate, keeping seasons steady enough for life to flourish. Without the moon, our nights would be darker, our tides weaker, and our planet's history might have unfolded along a very different path. What is most astonishing is that such violence could give rise to such serenity. We look up at the moon and see peace, a calm, silver disk shining softly through the night. But hidden beneath that stillness is the memory of fire, of shattered stone, of a world colliding with another in a dance of destruction and rebirth. So, when you see the moon tonight, remember that it is more than a companion in the sky. It is the child of catastrophe, a survivor of cosmic violence, and a reminder that even out of chaos, beauty can emerge. From the wreckage of planets, a gentle light was born, one that has guided Earth's oceans, shaped its rhythms, and watched over us ever since. Every night, the moon looks steady and unchanging in the sky. It has been there for as long as humans have told stories, as far back as the first creatures who dared to glance upward. Yet the truth is more subtle, more mysterious. The moon is not fixed in place. It is slowly, almost imperceptibly, drifting away from us, retreating at about 3.8 centimeters each year. That's roughly the speed at which your fingernails grow. It may sound like nothing at all. How could a few centimeters matter when the moon already hangs 384, 0 kilometers away. But over the span of millions, even billions of years, this steady drift changes everything. The moon was once much closer to Earth. In the beginning, when it first formed, it loomed enormous in the sky, so large that it might have filled half the horizon. Back then, the pull of its gravity created towering tides, hundreds of meters high, crashing across Earth's young oceans. Days were short, only a few hours long, because Earth spun so quickly under the moon's grip. The secret behind this slow separation lies in the delicate dance between Earth and its satellite. The moon's gravity pulls on our oceans, creating tides that rise and fall twice a day. But the Earth is rotating faster than the moon orbits. This mismatch means the bulges of water are always slightly ahead of the moon's position in the sky. Gravity tugs at those bulges, slowing Earth's spin ever so slightly, while at the same time giving the moon a push forward in its orbit. That push nudges the moon farther and farther away. It is a cosmic trade. Earth gives away a tiny bit of its rotation, and in return, the moon gains distance. This process has been going on for billions of years. Fossilized corals from 400 million years ago reveal that days on Earth once lasted only 22 hours. The moon was closer then, its pull stronger, the rhythm of life just a little faster. Every year since, our days have lengthened by fractions of a second, while the moon has inched outward, carving a wider circle around us. Astronauts and scientists have measured this drift directly. During the Apollo missions, astronauts placed reflective panels on the moon's surface. Today, scientists still bounce laser beams off those panels. By measuring the time it takes for the light to return, they can calculate the moon's exact distance down to millimeters. And with those measurements, they've confirmed what tidal theory predicts. The moon is escaping, centimeter by centimeter. What does this mean for the far future? In billions of years, Earth's rotation and the moon's orbit will eventually synchronize more completely. Just as the moon now always shows us the same face, Earth too may one day always show the same face to the moon. From one hemisphere, the moon would be frozen in the sky forever, never rising or setting. From the other hemisphere, it would never be seen at all. The tides would weaken, the dance would slow, and the balance would settle into a quiet stillness. But that future lies far beyond our time. For us, the moon's departure is gentle, invisible, almost tender. It is drifting away, yet it remains close enough to light our nights, to shape our oceans, to remind us that change is the heartbeat of the cosmos. Even when motion is too small to notice, it reshapes the destiny of worlds. So, when you look at the moon tonight, imagine it moving, slowly, silently, outward, not running away but gliding, a steady traveler widening its orbit around us. It has been drifting since the dawn of life, and it will keep drifting long after we are gone. And yet, no matter how far it goes, it will always carry with it the memory of Earth, the planet it was born from, the partner it has never left. The moon is leaving us, but it does so with infinite patience, a reminder that even separation can be beautiful when it unfolds in silence and in time. If you've ever gazed at the moon night after night, you may have noticed something curious. The dark patches, the bright highlands, the shape of its features, they never seem to change. The same face looks down on us every evening, as if the moon is a loyal companion, holding our gaze across time. This is not an illusion. The moon truly does always show us the same side. Scientists call this phenomenon tidal locking, and it is one of the quiet wonders of orbital mechanics. To understand it, imagine the early days of the Earth-Moon relationship. Billions of years ago, the moon spun much more quickly on its axis. As it orbited Earth, different sides faced us in turn, just as Earth spins to give us day and night. But over time, the pull of Earth's gravity created tides, not just in oceans, but in the moon itself. Though solid, the moon flexed slightly under Earth's pull, like a ball of clay being tugged in rhythm. With every stretch, friction inside the moon converted rotational energy into heat. This gentle braking slowed the moon's spin until it perfectly matched the time it takes to orbit Earth. Today, the result is what we see in the night sky, a moon that rotates once on its axis in the exact same time it takes to complete one orbit around Earth, about 27.3 days. This perfect synchrony means the same hemisphere of the moon always faces Earth, while the far side remains hidden. It is not truly dark, as it receives just as much sunlight, but it is forever turned away from our view, unseen until spacecraft revealed its rugged, cratered surface in the 20th century. Tidal locking is not unique to our moon. Across the cosmos, many worlds fall into this quiet rhythm. Mercury was once thought to be tidally locked to the Sun, though it actually has a different resonance. The moons of Jupiter and Saturn, like Europa and Enceladus, also show the same faces to their planets. It is a natural outcome of gravity's long patience. Given enough time, most close-orbiting bodies settle into this dance, one side forever turned toward their partner. For Earth, the effect is more than a curiosity. It shapes our experience of the moon in ways both practical and poetic. Generations of storytellers have looked up and woven myths about the familiar patterns on its surface: the man in the moon, the rabbit, the lady. These stories exist because the same face has always been visible. If the moon rotated freely, its features would shift constantly, and no enduring myths would have formed. Tidal locking gave us a stable canvas in the sky, one that cultures across the world painted with imagination. There is also comfort in this constancy. While stars rise and set, while planets wander along their paths, the moon's familiar face is steady, a reminder of continuity. It is the same view the first humans saw, the same that guided ancient navigators, the same that glowed on fields where early farmers worked by moonlight. Our ancestors lived entire lives under that one face, never knowing another existed on the far side. And yet, tidal locking also invites wonder. The far side, hidden for most of human history, is a reminder of mystery that even with something so close, half remains unseen. It was not until 1959, when the Soviet spacecraft Luna 3 sent back grainy images, that humanity first glimpsed it. Where the near side shows broad, dark plains, the far side is rugged, crowded with craters, and strangely different. Tidal locking both hides and reveals, reminding us that even in the familiar, there are always secrets waiting just beyond sight. So, when you look at the moon tonight, remember that it is not just a passive mirror in the sky. It is a dancer in perfect synchrony with Earth, locked in step for billions of years. One face forever turned toward us, one forever turned away, a cosmic embrace that has shaped myth, science, and the very rhythm of our nights. When you look up at the moon with the naked eye, you may notice dark, shadowy shapes across its bright surface. Some look like vast puddles, others like splashes of ink. Long ago, people thought these markings were oceans, and so they named them in Latin as Maria, meaning seas. Today, we know they are not filled with water, but with history. These Maria are enormous plains of ancient lava, frozen in time. Billions of years ago, the moon was not the silent, still body we see today. Its crust was young and fragile, scarred by giant impacts from asteroids and comets that rained down across the solar system. When these colossal impacts struck the moon, they cracked its surface and left behind deep basins. From within, molten rock seeped upward, flooding the lowlands. For a time, the moon glowed with volcanic fire, its wounds filled with rivers of lava that spread across hundreds of kilometers. When the lava cooled and hardened, it left behind the dark, smooth expanses we now see as Maria. Unlike the bright highlands, which are made of lighter, older rock called anorthosite, the Maria are rich in basalt, a darker volcanic rock that absorbs more sunlight and gives them their shadowed appearance. Together, they cover about 16% of the lunar surface, forming shapes so large they can be seen clearly from Earth with the naked eye. Over centuries, these patterns sparked the imagination of humans everywhere. Some cultures saw the face of a man gazing down from the moon, etched in the contrast between Maria and highlands. Others saw a rabbit, a toad, or a goddess. These myths were possible only because the Maria are permanent, unchanging features, etched into the moon for billions of years. One of the largest Maria, Mare Imbrium, stretches more than 100 kilometers across. It was born from an impact so violent that it reshaped much of the moon's northern hemisphere. Another, Mare Tranquillitatis, the Sea of Tranquility, holds a special place in human history. In 1969, Apollo 11 touched down on its basalt plains, and for the first time, humans set foot on another world. What ancient lava flows created billions of years earlier became the stage for one of humanity's greatest achievements. Though we once thought of them as seas, the Maria are dry and airless, with no waves, no water, no life. Yet, in their stillness, they hold a kind of quiet memory. They are records of a more active moon, when molten rock still pulsed beneath its crust, and the solar system itself was young and unsettled. Scientists believe the last volcanic eruptions on the moon ended about 1 billion years ago. Since then, the Maria have lain silent, preserved by the absence of wind, rain, or erosion. Even so, they are not without scars. Countless smaller craters dot their surfaces, reminders of meteorite impacts that continued long after the lava cooled. But the smoothness of the Maria, compared to the rugged highlands, tells us that these are younger features, younger in a lunar sense, meaning still billions of years old. When you look at the Maria through a telescope, or even with your eyes alone, you are not just seeing shadows. You are seeing the frozen aftermath of fire, the still surface of ancient lava oceans. They are seas without water, waves of rock stilled into permanence. So tonight, as the moon rises, take a moment to trace those dark shapes. Imagine rivers of molten rock spilling across the surface, glowing red against the black of space. Imagine the silence when they cooled, the stillness that followed, and the billions of years in which nothing disturbed them. The Maria are not seas, but they are oceans of time, holding the memory of a fiery moon long past. If the moon's Maria are seas of frozen lava, smooth and dark, then the highlands are their opposite. They shine brighter, like pale continents rising from a shadowed ocean. These rugged, elevated regions are the moon's oldest landscapes, ancient witnesses to the earliest ages of the solar system. When you look at the highlands through your eyes or a telescope, you are seeing some of the most ancient ground a human has ever beheld, older than Earth's tallest mountains, older than any ocean, older than life itself. The highlands are made of a rock called anorthosite, rich in a mineral known as feldspar, which reflects more sunlight and makes them appear brighter than the darker Maria. Unlike the smooth plains, the highlands are rough, jagged, and deeply scarred. Billions of years of impacts from asteroids and comets have left them pitted with craters of all sizes, shallow bowls, deep scars, and overlapping circles that tell the story of relentless bombardment. These scars are not just random marks. Each crater is a time capsule. Some formed more than 4 billion years ago, when the solar system was still wild and chaotic, filled with debris left over from the birth of planets. Others are younger, reminders that even long after the chaos settled, the moon continued to be struck by wandering rocks. Unlike Earth, the moon has no atmosphere, no rain, no winds, no flowing rivers to erase its wounds. The highlands keep their memories. They are a living record of cosmic collisions, stretching back almost to the beginning of time. The oldest regions of the highlands are thought to have solidified only a few 100 million years after the moon itself was born. Scientists believe that in its earliest days, the Moon may have been covered in a global magma ocean, a sea of molten rock created by the energy of its violent formation. As that ocean cooled, lighter minerals floated upward, forming a crust. Those lighter minerals became the bedrock of the highlands we see today. In this way, the highlands are the very crust of the newborn Moon, preserved across billions of years. Because they are so ancient, the highlands look dramatically different from the Maria. They are heavily cratered, with little sign of the volcanic resurfacing that smoothed over the lowlands. Peaks and ridges rise sharply, their edges untouched by erosion. From orbit, astronauts described them as breathtaking, like flying over a world frozen in its earliest chapter. To stand on their surface would be to step directly into the past, surrounded by landscapes that have remained unchanged for eons. Among the most striking highland features are the rims of giant impact basins. These are the scars of collisions so vast that they reshaped entire regions of the Moon. Some of these rims stretch for hundreds of kilometers, marking where asteroids the size of cities or small countries slammed into the surface. Each one is a silent monument to the violence of the early solar system, and yet, within their scars lies beauty. The highlands sparkle faintly with tiny crystals, and their bright surfaces shine in contrast to the darker Maria. Through a telescope, the highlands gleam like snowy plateaus, catching sunlight and giving the Moon its mottled, familiar face. Without them, the Moon would not have the same haunting expression we all recognize. When you look at the highlands, you are seeing more than just rock. You are seeing survival. These landscapes have endured billions of years without vanishing. They are older than the oldest fossils, older than any mountain range on Earth, older even than the oceans that cradle life. So tonight, as the Moon hangs in the sky, notice its bright patches, gleaming and scarred. Imagine the asteroids that carved them, the fire that once filled them, the silence that has preserved them ever since. The highlands are not just land, they are memory itself, written in stone, waiting for us to look up and remember. One of the most haunting truths about the Moon is that it remembers. On Earth, winds sweep across deserts, rains wash away trails, rivers carve valleys, and mountains slowly crumble. Time is always erasing and reshaping what we leave behind. But the Moon is different. It has no air, no rain, no flowing water. Without an atmosphere, it is silent and still, a world where nothing softens the marks of the past. This means that when the Apollo astronauts walked across its dusty plains, every step pressed into the lunar soil remained imprinted, crisp and sharp. In 1969, when Neil Armstrong stepped off the ladder of the lunar module and left the first human footprint on another world, he was not just making history for the moment. He was leaving a mark that may endure for millions of years. The surface of the Moon is covered in a layer of fine dust and crushed rock called regolith. It is created by billions of years of micrometeorite impacts. Without weather to erode it, the dust stays dry and powdery, clinging to everything it touches. When astronauts pressed their boots into this surface, the grains held their shape, undisturbed by wind or rain. The prints, tire tracks, and even equipment they left behind remain almost exactly as they were, frozen in time. Of course, the Moon is not completely immune to change. Micrometeorites, tiny fragments of rock and metal from space, strike its surface every day. Most are no larger than grains of sand, but over thousands of years, their steady bombardment slowly churns and reshapes the soil. Larger impacts, though rare, could eventually bury or destroy the evidence of human presence. Yet compared to Earth, where a footprint can vanish in days or even hours, the Moon is a realm of permanence. It is possible that long after our cities crumble and our mountains erode, the faint tracks of astronauts will still remain in the lunar dust, silent reminders of a brief visit by fragile beings from another world. The absence of atmosphere has other consequences too. On Earth, our air scatters light, creates blue skies, and softens temperatures between day and night. On the Moon, nothing moderates the harshness of space. Temperatures swing from searing heat in sunlight to freezing cold in shadow. The sky is always black, even at noon, and sounds cannot travel because there is no air to carry them. For the astronauts, every noise came only from within their helmets or through their radios. Outside, the landscape was silent, not quiet, but truly soundless. This silence is part of what makes those footprints so profound. They are marks left in a place where no wind will ever blow them away, no rain will ever wash them out, no rustling leaf will ever brush across them. They exist in a vacuum, carved into dust that has lain undisturbed for billions of years. There is something deeply human about this permanence. For as long as people have gazed at the moon, it was untouchable, unreachable, a distant lantern in the sky. Then, in a single generation, we crossed the gulf and set foot upon it. The prints we left are more than physical impressions. They are symbols of curiosity, courage, and the longing to explore. And perhaps that is what makes the moon so moving. On Earth, even the greatest monuments fade. But on the moon, fragile footprints can outlast empires. They remind us that our actions, however brief, can leave echoes that endure across time. So when you look at the moon tonight, imagine those tracks still resting quietly in the dust. The boot prints, the rover wheels, the scattered tools. They are still there, waiting in the silence. And unless the moon itself is struck by some great catastrophe, they may remain for millions of years a story written in dust. A reminder that once, humanity reached up and touched the sky. On Earth, we take the color of the sky for granted. At dawn, it glows pink and gold. At noon, it deepens into a brilliant blue. At night, it darkens into velvet sprinkled with stars. All of this is possible because of one invisible blanket: our atmosphere. Molecules of air scatter sunlight, bending it into shades that paint our skies with color and soften the boundaries between day and night. But on the moon, there is no such blanket. No air, no scattering, no veil of molecules to catch and diffuse the sun's light. The moon has no atmosphere, and so its sky is always black. Even when the sun hangs high above its surface, blazing fiercely onto the gray dust, the heavens remain a void of darkness, sprinkled with unblinking stars. To stand there in daylight is to live in a paradox. The ground burns with light, but the sky is eternal night. This stark difference puzzled the Apollo astronauts. As they stepped onto the lunar surface, they described an experience unlike anything on Earth. The sun was blinding, casting shadows sharp as blades. Yet above their helmets stretched a blackness so complete it seemed almost physical, as if they had landed inside a sphere of ink. There was no gradual blending of colors, no gentle fade from horizon to zenith, only the sharp contrast of brilliance and void. The reason lies in the physics of light. On Earth, sunlight enters the atmosphere and collides with nitrogen and oxygen molecules. Blue wavelengths, being shorter, scatter more easily, filling the sky with a dome of color. On the moon, sunlight travels unimpeded, striking the ground directly. There is nothing to scatter it sideways into a soft glow. The light is harsh, undiluted, and pure. Where it lands, it is bright. Where it does not, there is only darkness. This creates a strange visual world. In photographs from Apollo missions, shadows on the moon appear jet black, almost as if objects had been cut from the surface with scissors. Without air to bend or soften the light, there are no halftones, no gentle gradients. The moon's landscapes look sharp, crisp, and surreal, more like a dream than a world. The absence of atmosphere also means the stars are visible even during the day, though, in practice, the astronauts' eyes were overwhelmed by the sun's glare on the surface. Still, the idea is staggering. To stand in blinding sunlight while the Milky Way stretches overhead in its full glory. No blue sky to hide it, no haze to dim it. Just the sun, the land, and the infinite. This black sky has consequences beyond beauty. On Earth, our atmosphere helps regulate temperature, trapping heat and dispersing energy. On the Moon, nothing stands between the surface and the vacuum of space. In sunlight, the ground bakes at over 100 degrees Celsius. In shadow, it plummets below 150 degrees. Day and night are not just matters of light and dark, they are extremes of fire and ice. Yet, in this harshness, there is serenity. The Moon's black sky is not empty. It is a canvas for stars, planets, and galaxies that appear sharper than anywhere on Earth. Imagine lying on the surface and looking up, no twinkle, no shimmer, just steady points of light glowing as if they were within reach. It is the purest view of the universe, untouched by air or weather, unchanged for billions of years. So, when you see the Moon tonight, glowing softly above Earth's blue atmosphere, remember the difference. To us, it looks gentle, but to anyone standing there, it would feel like standing in the raw heart of space itself. The sun burns, the ground shines, but the sky is forever black. A silent reminder that the Moon lives not beneath the sky, but beneath the universe itself. When we imagine the Moon, we often picture its gentle glow, cool, silver, and calm in the night sky. But the reality of its surface is far harsher. Beneath that soft light lies a world of extremes, where temperatures swing wildly between scorching heat and bitter cold. The Moon, with no air to shield it, endures the raw power of the sun and the silence of deep space. On Earth, our atmosphere acts as a blanket. During the day, it scatters sunlight and spreads warmth across the planet. At night, it traps heat, preventing the world from cooling too quickly. But the Moon has no such protection. With no atmosphere to regulate temperature, its surface is at the mercy of the sun's rays. When the sun shines directly on the lunar soil, temperatures soar. The ground can heat to over 100 degrees Celsius, hot enough to boil water, hot enough to melt plastics, hot enough to turn any unprotected machine into a furnace. For the Apollo astronauts, this meant their suits and equipment had to be carefully engineered with reflective layers and cooling systems to survive the glare of the lunar day. In photographs, you can see the sharp contrast of blazing sunlight against the inky black shadows, where temperatures plunge in the opposite direction. Because if the Moon's days are searing, its nights are freezing. When the sun sets, there is nothing to hold on to the heat. Within hours, the warmth radiates away into space, and the surface plummets to below 150 degrees Celsius. In some regions, particularly deep craters near the poles that never see sunlight, temperatures can sink even lower, colder than anywhere on Earth, even colder than the surface of Pluto. These shadowed craters are so frigid that they can trap ice for billions of years, preserving frozen water like time capsules from the early solar system. This cycle of heat and cold is tied to the Moon's rhythm. A single day on the Moon, from sunrise to sunrise, lasts about 29 Earth days. That means 2 weeks of unbroken daylight, followed by 2 weeks of darkness. For half the month, the sun pours down relentlessly, baking the soil until it glows faintly with heat. For the other half, the cold of space creeps in, freezing the dust into silence. The Moon is not just a place of contrast, it is a place of extremes stretched across time. For astronauts, these conditions pose enormous challenges. Land during lunar day, and the heat becomes dangerous. Land during lunar night, and the cold is equally perilous. Future missions to the Moon will have to account for these swings, building shelters and systems that can withstand both fire and ice. The lack of atmosphere may give us clear skies and eternal stars, but it also means survival requires ingenuity. And yet, there is beauty in this starkness. Imagine standing on the moon at the moment of dawn, when the sun slowly climbs above the horizon after 2 weeks of darkness. The shadows shrink, the ground warms, and light floods a landscape that has been frozen in silence. Then imagine sunset, when the sun dips again, leaving the world to freeze under a black, star-filled sky. These changes are not gradual. Like Earth's twilight, they are sharp, absolute, almost theatrical, as if the moon itself lives between two extremes with no middle ground. So, when you look up at the moon tonight, remember that its gentle glow hides a harsh truth. It is a place of burning heat and deadly cold, of frozen craters and blazing plains, a world that teaches us how fragile warmth is and how precious the balance of Earth's atmosphere truly remains. The moon endures both fire and ice, silently, endlessly, beneath the same stars we see above us. When we look up at the moon, it often seems like a flat, glowing disk. Its shadows and patterns look painted on, like ink across parchment. But in reality, the moon is not flat at all. It is a rugged world, carved with valleys, cliffs, and towering mountains, some of them higher than Mount Everest here on Earth. Among these is Mons Huygens, which rises more than 5.5 kilometers above the surrounding surface, a peak as silent as it is ancient. These lunar mountains were not built the way Earth's were. On our planet, mountain ranges rise when tectonic plates collide, pushing up the land into jagged peaks. But the moon has no shifting plates, no continents grinding together. Its mountains are born instead from impacts, colossal collisions with asteroids that struck the moon billions of years ago. When these impacts carved out enormous basins, the crust rebounded and crumpled, leaving behind rings of jagged ridges and peaks. Mons Huygens, part of the Apennine mountain range, was formed this way, a scar that became a monument. Seen through a telescope, the lunar mountains are breathtaking. Their slopes cast long shadows when the sun is low on the horizon, stretching across plains of dust like dark fingers. Unlike Earth's ranges, softened by wind and rain, the moon's mountains are sharp and unweathered, their edges preserved for eons. They have stood untouched for billions of years, frozen in the shapes first carved by fire and impact. The Apennine Range, where Mons Huygens stands, borders the Mare Imbrium, the Great Sea of Rains. Billions of years ago, an asteroid slammed into the moon, creating a basin more than 1,000 kilometers across. Molten rock later filled the lowlands, forming the smooth plains of Mare Imbrium, while the edges of the basin lifted into rugged walls of stone. Mons Huygens towers among these, its summit rising into a sky that is always black, even at noon. For astronauts, such mountains are both inviting and dangerous. No human has ever climbed Mons Huygens, but from orbit, the Apollo crews described the ranges as spectacular, rising starkly against the flat Maria. Imagine standing at the base of such a peak, in a suit of white, staring upward at a summit higher than any you have climbed on Earth. There would be no snow, no forests, no rushing rivers, only sharp ridges of gray rock and dust, silent and still under the blazing sunday. The mountains of the moon are not lifeless in meaning. For ancient cultures, their shadows were part of the moon's mysterious patterns. Through early telescopes, astronomers like Galileo marveled at the jagged edges of lunar dawn, when sunlight struck the mountain peaks while valleys still lay in darkness. It was proof that the moon was not a perfect, polished sphere, as many once thought, but a rugged world of landscapes. And so, Mons Huygens and its neighbors are more than rocks in the void. They are reminders that even in silence, the universe builds grandeur. Without air or water, without tectonics or erosion, the moon still carries mountains tall enough to rival Earth's giants. Their endurance is part of their beauty. While Earth's mountains slowly crumble and shift, the moon's remain nearly unchanged, monuments to ancient violence and eternal stillness. When you see the moon tonight, picture those peaks cutting upward into the black sky. Imagine their long shadows stretching across gray plains, their summits glowing with sunlight while their bases rest in deep shadow. The mountains of the moon are not only taller than Everest, they are older than any mountain on Earth, guardians of a history written in stone and silence. When the Apollo astronauts stepped onto the moon for the first time, they discovered something remarkable. Their bodies, heavy on Earth, felt strangely weightless. With every step, they bounced and floated, their boots kicking up slow-motion sprays of dust that hung in the airless silence before drifting back down. This was not play acting. It was the reality of the moon's weaker pull. Its gravity is only 1/6 that of Earth's, and it transforms everything about how movement feels beneath its sky. Gravity is the invisible tether that holds us to the ground. On Earth, it gives weight to our bodies, pulls rivers downhill, and keeps the atmosphere wrapped around our world. But the moon, being smaller and less massive, exerts far less pull. A person who weighs 180 pounds on Earth would weigh just 30 pounds on the moon. The same legs that struggled to leap half a meter here could spring a meter or more there. For the astronauts, this change was liberating, but also challenging. Their bulky suits limited flexibility, yet the low gravity allowed them to move with ease, almost like children skipping across a playground. They quickly learned that the best way to travel was not to walk as on Earth, but to hop and bound in rhythmic strides. Watching them on film is like seeing humans rediscover the joy of motion, bodies suddenly freed from the constant weight of Earth's pull. This reduced gravity is not just a curiosity, it shapes the entire world of the moon. Rocks rest more lightly on the surface, so cliffs and craters can rise taller and steeper without collapsing. Dust, once kicked up, follows long arcs before falling back, unbent by air resistance. Even mountains like Mons Huygens are more stable because gravity does not drag them down as strongly. The whole landscape is a quieter, slower version of physics, where motion unfolds with elegance. The astronauts described the sensation as surreal. Imagine lifting a rock that would take effort on Earth, only to find it nearly floating in your hands. Imagine carrying heavy equipment, yet moving as though you were walking underwater, buoyant and free. They spoke of how easy it was to leap, how the ground seemed springy, how even a stumble turned into a graceful slide rather than a hard fall. The moon made them dancers, not by choice, but by nature. But this lighter gravity also comes with costs. Muscles and bones, built for Earth's weight, weaken in such conditions if they remain too long. On future missions, astronauts may need to exercise daily to keep their bodies strong, just as those on the International Space Station do in microgravity. Colonies on the moon would face the same challenge: how to stay healthy in a world where every step feels effortless, but the body slowly forgets its earthly strength. Still, there is wonder in imagining life under such a sky. A child born on the moon would grow up knowing a different kind of play leaps that soar meters high, games that seem like flight. Construction would be easier, heavy materials requiring only a fraction of the effort. And above it all, Earth would hang in the sky, glowing blue and white, reminding them of the stronger world where their ancestors first learned to walk. So when you see the moon tonight, remember that it is more than a pale companion. It is a world where gravity itself feels different, where weight is softened and motion is poetry. The astronauts' bouncing strides were not just a quirk of film, they were glimpses of a truth, that in another world, even walking can feel like flying. Though the moon hangs far above us, silent and untouchable, its influence reaches deep into our world. It is not only a light in the sky, it is a hand that stirs the oceans. Twice each day, Earth seas rise and fall in rhythm, swelling gently toward the moon and then sinking back again. This constant breathing of the waters is called the tides. and it is one of the moon's most enduring gifts to our planet. The secret lies in gravity. The moon's pull on Earth is strong enough to tug at everything, including the oceans. Because water flows, it responds most visibly. On the side of Earth facing the moon, water bulges outward, drawn toward it by gravity. At the same time, another bulge forms on the far side, caused by the inertia of the water as Earth and Moon orbit together. As Earth rotates through these bulges, coastlines around the globe experience high tide and low tide in steady succession. For people living near the sea, tides are a familiar rhythm. Fishermen have relied on them for thousands of years, planning their journeys with the rising and falling waters. Ancient cultures noticed the link between the moon's phases and the strength of tides, weaving it into myth and calendars. Even today, sailors, surfers, and scientists keep watch on the tides, knowing that the moon's pull still guides the oceans as faithfully as it did for our ancestors. But the tides are more than a curiosity of the sea. They shape life itself. Intertidal zones, the regions where land meets the ocean, are some of the most diverse habitats on Earth, precisely because they are ruled by tides. Twice daily, creatures here face two worlds, one of air and one of water. Crabs scuttle across exposed sand, barnacles close tightly against the dry air, and seaweeds bend back into the waves as the tide returns. Life has adapted to this lunar rhythm, turning the moon's pull into a heartbeat of ecosystems. The tides also reach farther than the shore. Their endless movement helps mix Earth's oceans, redistributing heat, nutrients, and energy across the globe. This circulation plays a quiet role in balancing climate, linking the moon's steady orbit to the living patterns of Earth itself. Without tides, the oceans might be more stagnant, less life-rich, less dynamic. There is another effect, more subtle but no less profound. As the moon pulls on our oceans, the oceans pull back on the moon. This mutual tug is what causes the moon to slowly drift away from Earth about 3.8 centimeters each year. In exchange, Earth's rotation gradually slows. Our days lengthen by tiny fractions of a second, while the moon climbs ever so slightly higher into its orbit. This exchange has been unfolding for billions of years, and it means that the length of a day, the distance to the moon, and the rhythm of the tides are all bound together in a cosmic balance. The next time you watch the sea roll in, think of this invisible connection. The waves that rise up the beach, the currents that sweep along the coast, are not just local forces of water and wind. They are part of a chain that stretches all the way to the moon. A silent partner in the sky is moving those waters, pulling and releasing, guiding and shaping. So, when you look at the moon tonight, remember, it does not simply light the night. It reaches into our oceans, into the pulse of life itself, keeping time with every tide. The seas breathe because the moon is there, pulling gently, endlessly, as it has since the world was young. Earth is not upright. It spins on a tilted axis, leaning gently at about 23.5 degrees. This tilt is the reason we have seasons. When one hemisphere leans toward the sun, it enjoys summer, while the other leans away and slips into winter. Without that tilt, there would be no dramatic swings of warmth and cold, no cycle of planting and harvest, no rhythm of spring blossoms and autumn leaves. The tilt gives Earth its seasonal heartbeat. But the tilt does not stand alone. It is stabilized by the moon. Astronomers have discovered that Earth's spin would be far more erratic without its lunar companion. Planets wobble naturally as they rotate, like a spinning top that slowly sways back and forth. Over long timescales, the gravitational tugs of other planets can shift that wobble, changing the angle of a planet's tilt. For Earth, those forces would be strong enough to throw the axis into chaos, sometimes leaning more steeply, sometimes less, perhaps even toppling over. If Earth's tilt wandered this way, our climate would be wildly unstable. summers could grow unbearably hot, winters unimaginably cold. At times, the poles might even tilt toward the sun, melting ice caps completely, while other times the planet could freeze in near-permanent winter. Such violent swings would make life far harder to sustain. Some scientists believe that without the moon's steadying hand, Earth might not have developed the stable environment that allowed complex life, including humans, to flourish. The moon stabilizes Earth's tilt through its gravity. By orbiting around us, it acts like a counterweight, tugging gently on our equatorial bulge, the slight widening of Earth at its middle due to rotation. This gravitational pull dampens the wobble, keeping the tilt confined to a narrow range. Instead of swinging between extremes, Earth's tilt drifts only by a few degrees over tens of thousands of years. These small shifts shape natural cycles like ice ages, but they do not plunge the planet into chaos. In this way, the moon has been our quiet guardian for billions of years. This influence is subtle, invisible in daily life, but profound across time. Every summer we enjoy, every winter we endure, is possible because the moon keeps Earth balanced. The harvests of ancient civilizations, the migrations of animals, the flow of ecosystems all have unfolded under the moon's patient watch. It has not only pulled at our oceans, but at our very stability, ensuring that the planet remains a home for life. Consider what this means in the deep history of Earth. While comets bombarded the young world, while continents drifted and mountains rose, the moon was always there, holding Earth steady. While ice ages came and went, while forests spread and deserts shrank, while humans learned to sow seeds and raise cities, the tilt remained gentle, never tipping too far. The moon may seem small compared to Earth, but its presence has shaped our destiny. And so, when you look at the moon tonight, remember that it is not just a light in the sky. It is the anchor of our seasons, the keeper of balance, the quiet hand that steadies the spinning Earth. Without it, the world might tilt wildly, a planet of extremes, harsh and unstable. With it, we live in a world of rhythm, spring following winter, summer following spring, endlessly, predictably, for billions of years. The moon is our guardian of time, a silent partner in the dance of seasons. Its presence means that when blossoms return each spring, when snow falls each winter, we are witnessing not just Earth's cycles, but the balance kept by a companion that has never left our side. On Earth, the cycle of day and night feels natural and familiar. The sun rises, arcs across the sky, and sets, all within 24 hours. But on the moon, time moves differently. There, a single day from one sunrise to the next lasts about 29 Earth days. To stand on the lunar surface is to live inside a day that stretches nearly a month long, with 2 weeks of unbroken sunlight followed by 2 weeks of deep, endless night. This rhythm is tied to the moon's rotation and orbit. The moon spins on its axis once every 27.3 Earth days, the same time it takes to complete one orbit around Earth. Because of this synchrony tidal locking, the moon always shows us the same face. But it also means that the rising and setting of the sun on the lunar horizon are drawn out across an enormous stretch of time. What we call a day on Earth sunrise to sunrise is stretched on the moon to nearly 29 days because of the added effect of Earth's motion around the Sunday. Imagine standing at the edge of a lunar dawn. Slowly, almost imperceptibly, the sun peaks above the horizon. There is no rush of color, no golden scattering of light, because there is no atmosphere to bend and soften the rays. The sun climbs directly into a black sky, the ground beneath your feet glowing gray and silver. Over the hours and days, the light grows hotter and harsher, baking the dust into silence. Shadows shrink and sharpen, and the temperature soars above 100 degrees Celsius. But the sun will not set that evening. It will remain overhead for nearly 14 Earth days, unblinking, relentless. For 2 Earth weeks, the landscape is drowned in sunlight, a world without true night, where shadows cut like ink and the horizon glows with unbearable brightness. Then, at last, the sun begins to sink. Its fall is as slow as its rise, a drawn-out descent that takes days to complete. When it finally slips below the horizon, darkness does not bring relief. It brings cold. For the next 14 Earth days, the moon lies in shadow. The temperature plunges to below 150 degrees Celsius. The land, once blazing, becomes frozen. No twilight softens the transition. No atmosphere catches the light of the setting sun to leave streaks of color. The shift from day to night is absolute, like the flip of a cosmic switch. Only the stars remain, sharper and steadier than we ever see them from Earth, filling the black sky with endless points of light. For astronauts, this long day-night cycle poses unique challenges. On Earth, solar panels rest at night and recharge by morning. On the moon, they would lie in darkness for 2 full weeks, while temperatures would threaten to freeze machinery solid. Any human settlement will need to withstand both blazing sunlight and bitter cold, surviving the extremes of a day that feels more like a season. Yet, for all its harshness, there is beauty in the lunar day. Imagine watching the Earth rise above the horizon, glowing blue and white, while the sun blazes on the other side of the sky. Imagine standing through an entire lunar sunrise, the slow climb of light that unfolds not in minutes, but in days. Time itself feels different on the moon, stretched out into a slower rhythm, reminding us how tied we are to Earth's quick turning. So, when you look at the moon tonight, remember, behind that calm glow lies a world of long days and longer nights. A place where sunrise lasts days, where noon burns for weeks, and where night endures half a month. The moon teaches us that not every world spins to Earth's rhythm. Some turn slowly, patiently, marking time in silence, a day that is almost a month long. For as long as humans have gazed upward, the moon has shown us only one face. Its dark Maria and bright highlands, its familiar shapes and patterns, have watched over us for millennia. This is because of tidal locking. The moon rotates in sync with its orbit, always keeping the same hemisphere turned toward Earth. That hidden half, the one we never see from the ground, has long been called the dark side of the moon. But the name is misleading. It is not truly dark. The far side receives just as much sunlight as the side we see. Its darkness lies only in our ignorance, not in the absence of light. Before the space age, no human had ever glimpsed this hidden world. For thousands of years, poets and dreamers could only imagine what lay beyond the moon's visible edge. Some thought it might be smooth, others imagined whole new continents of mystery. It wasn't until 1959, when the Soviet spacecraft Luna 3 flew behind the moon, that humanity saw its far side for the first time. The images revealed a startling truth. The far side looks very different from the familiar face that gazes down on Earth. On the near side, broad, dark plains of frozen lava, the Maria spread across the surface. These shapes form the patterns we call the man in the moon, or the rabbit. But on the far side, Maria are scarce. Instead, it is dominated by rugged highlands, heavily cratered and ancient, a surface more scarred and chaotic. The largest and deepest impact basin in the solar system, the South Pole, Aitken Basin, lies there, stretching more than 500 kilometers across. The far side is not dark at all. It is dramatic, jagged, and strange. Why the difference? Scientists believe it may be due to the moon's early history. The near side's crust is thinner, allowing magma to seep out and fill basins with lava, forming the dark Maria. The far side's crust is thicker, holding back volcanic flows. Over billions of years, this imbalance created 2 moons in one. The near side we know, and the far side that remained hidden until modern times. The phrase "dark side of the moon" still lingers in culture, in music, in myth. But the reality is subtler and richer. The far side experiences the same cycle of day and night as the near side, 2 weeks of sunlight, followed by 2 weeks of shadow. At lunar noon, its surface blazes just as hot. At midnight, it freezes just as cold. The difference is not in light, but in perspective. From Earth, we never see it. From the far side, Earth itself never rises. The blue planet remains forever hidden below the horizon. Today, orbiters and rovers have mapped this hidden hemisphere in detail. China's Chang'e 4 mission even landed a rover, the first to explore the far side directly. Its instruments study craters, rocks, and radiation in a world that has been shielded from Earth's radio noise. The far side, once a symbol of mystery, has become a frontier for science, teaching us about impacts, lunar history, and the quiet environment of space. Still, there is something poetic in knowing that half the moon was unseen by humans for all of history. That, when our ancestors told stories under its glow, they were speaking only of one face, unaware of the other, silently turning away. The moon reminds us that even the closest companions can hold secrets, and that mystery is not always far away. Sometimes it is just on the other side. So when you hear the phrase, "the dark side of the moon," remember, it is not dark. It is simply hidden, a world bathed in sunlight just like the side we see, waiting patiently to be discovered. The near side of the moon is like an old friend. Its familiar patterns of dark plains and bright highlands have stared down at Earth for as long as humans have existed. We know its shapes by heart: the man in the moon, the rabbit, the shadowy seas. But the far side, forever hidden from our view, tells a very different story. It is a face we never see, a landscape more rugged, more mountainous, and strangely lacking the broad, dark Maria that define the near side. When the Soviet spacecraft Luna 3 first photographed the far side in 1959, the world was astonished. Instead of the dark patches that give the near side its expression, the far side was covered in a pale, battered crust. Vast highlands stretched across the surface, scarred by countless craters, their jagged rims overlapping like rings in a tree trunk. There were hardly any Maria at all, no great seas of lava to smooth the surface. The far side was rough, chaotic, and ancient, a contrast so sharp it seemed like two different worlds stitched into one. The reason lies in the moon's early history. Billions of years ago, when asteroids slammed into the surface and created giant basins, magma welled up from the interior to fill them. On the near side, where the crust is thinner, these lava floods spread widely, hardening into the smooth plains we see as Maria. But on the far side, the crust is thicker. The molten rock could not break through so easily. The impacts left their scars, vast craters and basins, but they were never filled, never softened. Instead, the far side kept its jagged mountains and rugged highlands, a fossilized record of collisions that never healed. One of the most striking features is the South Pole Aitken Basin, one of the largest impact structures in the solar system. Over 500 kilometers wide and 13 kilometers deep, it gouges the far side with a scar so immense it defies comprehension. Yet even here, there are no great seas of basalt like Mare Imbrium or Mare Tranquillitatis on the near side. The basin remains rough and ancient, its wounds unfilled. Standing there, the view would be utterly different from the landscapes of the near side. No smooth plains stretching to the horizon, no dark seas blending into the glow. Instead, mountains rise sharply from the dust, their jagged peaks catching sunlight, while deep craters remain cloaked in shadow. The terrain is harsh, fractured, almost alien, and yet it is part of the same moon that looks so calm from Earth. The far side's ruggedness also hides another difference: silence. Because the moon always keeps one face toward Earth, the far side is shielded from our planet's constant radio chatter. For scientists, this makes it an ideal place to listen to the universe, a quiet zone where telescopes might one day study faint signals from the cosmos without interference. Its isolation, once a symbol of mystery, is now seen as an opportunity. Culturally, the far side has long stood as a metaphor for the unknown. For millennia, people imagined what it might hold: secret lands, hidden civilizations, untouched worlds. In truth, it holds something quieter but no less profound: the oldest, most unbroken record of the solar system's history. While the near side tells a story softened by lava, the far side keeps every scar, every mountain, every crater intact. So, when you look at the moon tonight, remember that half of it remains unseen, not dark, not absent, but rugged and strange, a face turned forever away from us, its mountains rising in silence, its craters untouched by seas of lava. The moon, our constant companion, is not one world but two, bound together: the familiar face we know, and the hidden face that waits, scarred and eternal, on the other side. The moon wears its history on its face. Every crater, every ridge, every plain of dark rock is a mark left behind by collisions stretching back billions of years. But among all of these scars, one stands out as the largest and most profound: the South Pole Aitken Basin, stretching over 500 kilometers across and plunging 13 kilometers deep. It is not only the biggest impact feature on the moon, but also one of the largest in the entire solar system. It is a wound so vast it reshaped the moon itself. To imagine its size, think of it this way: the basin covers nearly a quarter of the lunar surface. If you stood on one rim and looked across to the other, you could not see it. The curvature of the moon would hide the far side. It is an impact scar on a planetary scale, the kind that could only be created in the violent chaos of the early solar system. Scientists believe the basin formed more than 4 billion years ago, when a massive asteroid or protoplanet struck the moon at incredible speed. The impact was catastrophic. It blasted away rock, melted crust, and excavated material from deep inside the moon's mantle. The force of the collision was so immense that it nearly split the moon apart, and yet somehow our satellite endured. What remained was this enormous basin, a reminder of a time when the skies were filled with wandering giants, and collisions shaped the destinies of worlds. Unlike the Great Maria on the moon's near side, the South Pole Aitken Basin was never filled with seas of lava. Its rugged floor remains uneven, littered with mountains, ridges, and smaller craters carved long after the original impact. Its walls rise jagged and steep, encircling a depression so wide it defies perspective. And within it lies a mystery: material from the moon's interior that may have been revealed by the impact. Some scientists hope that by studying the basin closely, we can learn not only about the moon's crust and mantle, but also about the history of impacts across the solar system. Because of its age and scale, the South Pole Aitken Basin is like a natural laboratory frozen in stone. It tells us about the late heavy bombardment, a period when asteroids rained down on the inner planets, shaping their surfaces forever. On Earth, erosion and tectonics erased most of these scars, but on the moon they remain, silent witnesses to that ancient storm. The basin is perhaps the most dramatic of them all, a reminder of the violence from which stability was born. In recent years, spacecraft have mapped the basin in detail. They have revealed unusual variations in gravity, suggesting that dense material from the moon's interior lies beneath the surface. This supports the idea that the impact excavated the mantle, bringing clues from deep inside the moon closer to the surface. Future missions may one day land there, to collect samples and solve questions that have lingered for decades. What exactly struck the moon? How hot did the surface become? What secrets of the solar system are locked within this scar? And yet, beyond the science, there is something humbling about its sheer scale. The South Pole Aitken Basin is not just a geological feature. It is a story of survival. The moon absorbed a blow powerful enough to transform it forever, and still it remains, circling Earth in silence, its wound turned away from our gaze. From Earth, we cannot see it. The basin lies on the far side, hidden from our eyes, known only through spacecraft. It is a secret the moon keeps from casual stargazers, a reminder that even the most familiar companions hold mysteries just out of view. So tonight, when you see the moon's calm face, remember that on its hidden half lies a scar larger than any continent, older than any mountain, deeper than any ocean trench. The South Pole Aitken Basin is the moon's greatest memory of a time when worlds collided, a scar that speaks not only of violence, but of endurance. When you look at the moon through your eyes alone, it already seems marked and pitted, like an old face lined with memory. Through a telescope, the detail sharpens. Circular craters overlap one another, rims rise like frozen waves, and shadows stretch across vast basins. These craters are not random. They are stories, records of a time when the solar system was young and chaotic, a time when collisions shaped the fates of planets. The moon's craters are a map of violence written in stone. Billions of years ago, the early solar system was a crowded place. Planets had just formed from swirling clouds of dust and gas, but leftover fragments still wandered through space. Asteroids, comets, and small proto-worlds. They collided often, smashing together in explosions of fire and molten rock. On Earth, the scars of this age have been erased by wind, water, and shifting continents. But the moon has no atmosphere, no oceans, no tectonic plates. It remembers everything. Its craters are time capsules, preserving the evidence of those long-ago impacts. Some craters are tiny, no bigger than a coin would appear at arm's length. Others are immense, hundreds of kilometers wide, carved by asteroids the size of mountains. The Tycho crater, for example, stretches 85 kilometers across, its bright rays of ejected material spreading thousands of kilometers outward like the splash of a stone in water. The Copernicus crater, another giant, reveals terraced walls and a central peak formed when the lunar surface rebounded like liquid after the impact. Each of these features tells scientists about the size, speed, and angle of the collisions that made them. By studying craters, astronomers can reconstruct the history of bombardment that shaped not just the moon, but Earth and every planet. The density of craters in a region can reveal its age. Heavily cratered highlands are older, while smoother maria are younger, resurfaced by lava flows that buried older impacts. This contrast lets scientists piece together a timeline of lunar history and, by extension, the history of the solar system. The craters also hold clues to specific events, such as the Late Heavy Bombardment, a period around 4 billion years ago when asteroids and comets swept through the inner solar system, striking planets and moons with ferocity. On Earth, this may have boiled oceans, reshaped continents, and influenced the very beginnings of life. On the moon, the evidence is still visible, a frozen record of a storm that raged across worlds. But these craters are not only scientific records, they are also windows into beauty. At lunar sunrise, when the sun's light strikes the edges of craters at low angles, their rims glow while their floors lie in shadow. The contrast is breathtaking, like mountains seen at dawn, their peaks lit while valleys remain in night. Astronauts orbiting the moon described the surface as haunting and magnificent, every crater a silent monument to an ancient collision. On Earth, we see only echoes of such violence. A few scars remain craters in Arizona, South Africa, Siberia, but most have been erased by time. The moon, unchanging, holds them all. It is not just a companion in the sky, but a record keeper, showing us what our own planet endured in its youth. Without the moon's memory, much of the story of our solar system's violent past would be lost. So, when you see the moon tonight, take a moment to look closely at its face. Each circle, each shadow, each jagged rim is a scar, but also a story of fire, of stone, of worlds colliding and surviving. The moon is not only beautiful because of its glow, it is beautiful because it remembers. Most of the moon bakes under the unfiltered glare of the sun, or freezes under the endless chill of night. But in certain places, deep within craters near the poles, sunlight never touches the ground. The walls of these craters rise so high, and the sun stays so low on the horizon that their floors remain in shadow, not for hours or days, but for billions of years. These are the permanently shadowed regions of the moon, and in these cold, dark sanctuaries, temperatures plunge lower than anywhere on Earth, cold enough to preserve something precious: frozen water. It may seem impossible that ice could survive on the moon. With no atmosphere to shield it, sunlight is merciless, driving daytime temperatures above 100 degrees Celsius. At night, the land freezes to 150. Any exposed water would boil away or vanish into space. Yet, in these shadowed craters, where the sun has never risen, the cold is constant and unbroken. Temperatures drop below 200 degrees Celsius, creating freezers so deep that water molecules, delivered by comets or formed from solar wind interactions, can accumulate and remain intact for eons. These icy deposits are not vast oceans, but thin layers mixed with dust, frost clinging to grains of soil, and perhaps thicker slabs hidden beneath the surface. Radar and spectrometer readings from spacecraft like NASA's Lunar Reconnaissance Orbiter and India's Chandrayaan-1 have revealed signs of this water ice. The craters themselves, places like Shackleton Crater near the South Pole, have become targets of intense interest, not just for scientists, but for the future of human exploration. For researchers, the ice holds clues to the moon's history. Each frozen molecule may carry the fingerprints of its origin, whether from comet impacts, ancient volcanic outgassing, or the steady rain of hydrogen from the sun colliding with oxygen in the soil. By studying it, we may learn about the flow of water across the solar system, and even the story of how water first arrived on Earth. For explorers, the ice represents something even more practical. A resource. Water is heavy, and carrying it from Earth is costly. But ice on the moon could be melted for drinking, split into oxygen for breathing, or even converted into hydrogen and oxygen fuel for rockets. These shadowed craters, once symbols of eternal darkness, may become oases for future lunar bases, refueling stations, and shelters for humans learning to live beyond Earth. Yet, beyond the science and utility lies the poetry of these places. Imagine standing at the rim of such a crater, sunlight blazing at your feet, while just meters away lies a darkness untouched since the moon was born. Inside, the cold is deeper than Antarctica, a silence so profound that even light has never entered. Somewhere in that blackness lies frost that has survived for billions of years, older than humanity, older than life itself. The contrast is striking. On one side, the blinding sun, sharp shadows, and gray dust glowing white-hot. On the other, eternal night and ancient ice, glimmering faintly if illuminated by a rover's light. It is a reminder that the moon is not uniform, not simply a dead sphere of rock, but a place of secrets, extremes, and hidden treasures. So, when you see the moon rise tonight, remember, beyond its glowing face are shadows deep enough to hide time itself. In those craters, frozen water waits, untouched and ancient, whispering of comets, of stars, of beginnings. The moon, so silent and still, holds within its darkest corners the memory of water and perhaps the promise of our future among the stars. For billions of years, the moon has circled Earth in silence, a barren companion of rock and dust. But hidden in its deepest shadows, in craters that never see the sun, lies something extraordinary: frozen water. These deposits of ice, ancient and untouched, may hold the key to turning the moon from a place of brief visits into a place where humans could live. They are not just scientific curiosities, they are resources, the building blocks of a future lunar home. Water is life. On Earth, it shapes landscapes, nourishes every living thing, and sustains our bodies with every breath and sip. In space, water is even more precious. Carrying it from Earth is costly. Every liter must be launched through gravity's grip at tremendous expense. But if explorers can find and use the water already on the moon, a new horizon opens. Suddenly, the moon is not just a destination, but a base, a stepping stone into the wider solar system. How could frozen water in lunar craters support human colonies? First, it could simply be melted and purified for drinking. Astronauts who stay for months or years would no longer need to depend entirely on supplies from Earth. Second, water could be used to grow food. Hydroponic systems, nourished by melted ice, could allow plants to thrive inside pressurized habitats. Green sprouts, under artificial light, would be a miracle in the gray emptiness of the moon. But water holds another gift. It can be broken down into its elements: hydrogen and oxygen. With electricity, perhaps from solar panels or nuclear power, this process, called electrolysis, could provide oxygen for breathing and hydrogen for rocket fuel. Imagine lunar bases refueling spacecraft with water mined from shadowed craters, turning the moon into a launch pad for journeys deeper into space. Mars, asteroids, and beyond could all become more reachable, thanks to the frozen reserves lying in the moon's eternal night. The idea of a colony on the moon is no longer science fiction. Space agencies and private companies are already studying how to extract and use lunar ice. Robots may one day scoop the dusty frost, heat it, and collect the vapor, storing it for human use. Shelters could be built near the poles, where sunlight provides power but nearby craters hold ice. The first permanent lunar settlement may rise not in the bright Maria, but on the rim of a shadowed basin, balanced between light and darkness. And yet, the dream of lunar colonies is not only about survival. It is about hope. To live on the moon would be to take humanity's first true step beyond Earth, to become a species not bound to a single planet. The ice in those craters may help us achieve that. What has remained untouched for billions of years could one day sustain entire communities of explorers, scientists, and dreamers. There is poetry in this vision. Imagine standing inside a lunar habitat, looking out at the gray dust and black sky, knowing that the water you drink was once ice hidden in darkness older than any civilization. Imagine children born under Earthrise, their lives made possible by frost, delivered by ancient comets. Imagine rockets lifting from the moon's surface, carrying fuel made from melted shadow. The moon, once only a symbol in our skies, would become a partner in our journey outward. So when you look at the moon tonight, remember, in its darkest places lies a promise. Ice that has slept for billions of years may one day awaken to sustain human life. From those frozen shadows, colonies could rise, and humanity's story could stretch beyond Earth. The moon, once only a destination, could become a home. When the Apollo astronauts returned from their moonwalks and stepped back into the safety of their lunar modules, they carried more than rocks and dust on their suits. They carried a smell. As they removed their helmets, they noticed an odor clinging to their gloves, boots, and equipment. A sharp, metallic scent like spent gunpowder after fireworks or a rifle's shot. It was the moon's dust, bringing with it the unexpected fragrance of another world. The moon has no air, no wind to carry smells as we know them on Earth. Out on the lunar surface, the silence is absolute. The only sensations are what you see, touch, and feel. But inside the cabin, once the fine gray dust clinging to their suits was exposed to oxygen, it released this strange scent. Astronauts compared it to ashes, to burnt matches, to gunpowder, a dry, acrid odor that filled the small space with the essence of the moon. What causes this peculiar smell? Scientists believe it has to do with the nature of lunar dust, or regolith. For billions of years, the moon has been bombarded by micrometeorites, tiny fragments of rock and metal traveling at tremendous speeds. Without an atmosphere to slow them, they strike the surface directly, shattering rock into powder and heating it to high temperatures. This process fuses grains into sharp, jagged fragments, sometimes coated with glassy surfaces. The dust is not soft like beach sand. It is abrasive, clinging, and chemically active. On the airless moon, this dust is exposed to the solar wind streams of charged particles from the sunday. These particles embed themselves in the grains, altering their chemistry. When astronauts brought the dust into the oxygen-rich environment of their cabin, the particles reacted, releasing volatile compounds that produced the smell of gunpowder. It wasn't gunpowder at all, but the result of space-weathered minerals suddenly meeting air. The astronauts' descriptions are some of the most human details of lunar exploration. Beyond the grandeur of Earthrise and the silence of the craters, there was this small sensory surprise. The moon has a smell. It makes the experience tangible, grounding the cosmic adventure in something intimate. Neil Armstrong, Buzz Aldrin, and others all noted it. To them, the moon was not just distant and abstract. It was real, dusty, and fragrant in its own peculiar way. But lunar dust was more than just a curiosity. It posed problems too. Its fine grains clung stubbornly to suits, scratching visors, clogging joints, and irritating lungs when particles floated inside the cabin. Some astronauts experienced what they called lunar hay fever, sneezing, watery eyes, scratchy throats. The dust was alive in its own way, clinging like static electricity, impossible to ignore. Future explorers will need to design habitats and suits that protect against it, learning to live with a substance as sharp as glass and as stubborn as ash. And yet, there is a strange poetry in knowing the moon has a scent. It means that when humans walked there, they didn't just see and hear, they smelled. They experienced it with senses that connected the alien to the familiar. The odor of dust tied the moon, for a moment, to earthly memories of fire and ash, reminding the astronauts that even on another world, some sensations still feel close to home. So, when you look at the moon tonight, imagine its dust sharp, ancient, and strange, clinging to a boot and releasing its ghostly smell inside a tiny spacecraft. Imagine the surprise of those first explorers, breathing in the scent of a place untouched for billions of years. The moon has no air, no breeze, no flowers, and yet, in its own way, it carries a fragrance. The scent of dust, the scent of time, the scent of a world beyond Earth. Every step the Apollo astronauts took on the moon stirred clouds of powdery dust, rising in graceful arcs before settling back to the surface. To the eye, it looked soft, almost like ash or talcum powder. But up close, lunar dust is very different. It is sharp, clingy, and stubborn, a substance forged by billions of years of micrometeorite strikes on a world without wind or rain to wear its edges smooth. On Earth, sand on a beach is rounded and polished by water and air. Waves tumble grains together, smoothing them into tiny spheres. Winds drive them across deserts until they shine. But the moon has no oceans, no breezes, no rivers. Its dust, called regolith, has never been softened. Each grain is jagged, with glassy shards and razor-like edges, the result of countless impacts from micrometeorites traveling at cosmic speeds. These micrometeorites, no larger than grains of sand themselves, strike the moon every day. Without an atmosphere to burn them away, they slam into the surface at tens of kilometers per second, shattering rock into ever finer fragments. The impacts generate heat so intense that some of the debris melts into glass, which then fuses with other particles. Over billions of years, this relentless bombardment ground the surface into a layer of dust that can be several meters deep in some places. Every step on the moon is into a powder created not by time and weather, but by violence and silence. The astronauts quickly learned how clingy this dust could be. It stuck to their suits, boots, and gloves like burrs, refusing to shake off. Its jagged edges caught on fabric and scratched visors. Inside the lunar module, it floated into the air, irritating their eyes and throats, leaving behind the acrid smell of gunpowder. "It's everywhere," they reported, brushing at their suits only to find the dust clinging tighter, as though it wanted to stay. The sharpness of lunar dust is not just inconvenient, it can be dangerous. In the low gravity, particles kicked up by movement settle slowly, coating equipment and seeping into every crevice. Future lunar explorers will need to protect machines and habitats from its abrasive bite. Scientists worry it could damage lungs if inhaled for long periods, its shards cutting into delicate tissue. Living with lunar dust will be one of the great challenges of building a colony on the moon. Yet there is something awe-inspiring about this dust as well. Each particle is ancient, a record of cosmic weathering that has shaped the moon for 4.5 billion years. Many grains contain tiny glass beads formed in the fire of impacts, some preserving chemical traces of solar wind that has blown across the solar system for eons. To hold lunar dust is to hold time itself, fragments of stone that have not changed since before life began on Earth. The dust also contributes to the moon's haunting appearance. Because its particles scatter light in unique ways, the moon glows with its familiar silvery sheen when seen from Earth. That shimmer we admire in the night sky is the reflection of countless sharp-edged grains, lying in stillness, untouched except for the brief moments when human boots disturbed them. So when you see the moon tonight, think of the dust. Think of the tiny meteors that rained down for billions of years, grinding rock into powder sharp enough to cut and fine enough to cling forever. Think of the astronauts brushing at their suits, the smell of gunpowder filling their cabin, the dust settling back after being lifted for the first time in ages. The moon is not smooth or soft. It is covered in dust that remembers dust shaped by fire, by collisions, by time itself. On Earth, change is constant. Winds sweep across deserts, grinding dunes into new shapes. Rivers carve valleys, rains wash mountains into the sea, and glaciers scrape rock into plains. Even the hardest stone cannot resist forever. Our world is alive with weather, and time always leaves its mark. But on the moon, time feels different. There is no air to carry wind, no water to flow in rivers, no rain to fall from clouds. The moon has no atmosphere thick enough to shape its surface. Its rocks, once broken or scarred, stay as they are. Its craters remain sharp for billions of years. Its landscapes are frozen in time, untouched by the constant reshaping that defines Earth. Imagine standing at the rim of a lunar crater. On Earth, its edges would crumble, worn down by frost and rain. Plants would creep in, roots splitting the stone. Eventually, it would become almost invisible, a gentle hollow instead of a sharp scar. But on the moon, a crater carved 4 billion years ago still looks fresh, its rim jagged, its floor shadowed. The silence has preserved it, keeping the violence of its birth written clearly in stone. This stillness makes the moon a natural time capsule. When scientists study its surface, they are not just seeing the moon's history, they are seeing the history of the entire solar system. The countless impacts recorded on its face are evidence of the storms of rock and ice that once swept through space, colliding with young worlds. Earth lived through those same storms, but weather and tectonics have erased most of its scars. The moon remembers what Earth has forgotten. Even small things endure. The Apollo astronauts left behind footprints, rover tracks, and instruments more than 50 years ago. On Earth, such traces would fade in weeks, washed away, blown away, covered by new growth. But on the moon, they remain as clear as the day they were made. With no wind to blur them, no rain to wash them, they could last for millions of years. Silent signatures of humanity's first steps on another world. The lack of weather also gives the moon its striking appearance. Shadows fall hard and sharp, with no air to scatter light and soften their edges. Rocks look crisp and jagged, as though sculpted yesterday. Even the dust lies undisturbed, except when a meteorite falls from space and churns it anew. Where Earth's landscapes are dynamic and alive, the moon's are still and enduring, each feature a frozen moment in deep time. Yet this timelessness does not mean the moon is entirely unchanging. Micrometeorites still rain down daily, tiny specks that strike the surface and grind it slowly into dust. Larger impacts, though rare, still carve new craters. But compared to Earth, these changes are glacially slow, measured not in years but in billions of years. To the human eye, to the span of human history, the moon seems eternal. There is beauty in this permanence. To walk on the moon is to touch history itself, rocks that have lain in place since before life began on Earth, craters that record the first collisions of planets, dust that has been undisturbed for eons. It is a reminder that not all worlds flow and shift. Some keep their past etched on their surface, waiting patiently for us to read it. So, when you look at the moon tonight, remember, what you see is not just a glowing orb in the sky. It is a frozen record of time, a landscape untouched by weather, unsoftened by air or water. It has held its scars for billions of years, and it will hold them for billions more. The moon does not forget. Beneath the boots of the Apollo astronauts, mixed with the gray powder of lunar soil, lay treasures too small to notice at first glance. Hidden among the dust are tiny glass beads, some no larger than grains of sand, sparkling under a microscope like droplets of frozen fire. These fragile spheres are more than curiosities. They are relics of the moon's fiery past, created by ancient volcanic eruptions billions of years ago. Long ago, the moon was not the still, silent world we see today. Its interior still burned with heat left over from its violent birth. Deep beneath the crust, molten rock bubbled and churned. At times, pressure built until fiery fountains erupted, spraying streams of lava into the skyless void. Unlike Earth, where eruptions are veiled by thick clouds of ash and steam, lunar eruptions unfolded in silence under a black sky. Lava spewed upward, glowing red against the stars, and droplets of molten rock arced through the low gravity before falling back to the ground. As these droplets cooled in the cold vacuum of space, they solidified into perfect spheres of glass. Over time, they settled into the dust, mixing with shattered rock and meteorite fragments. Billions of years later, astronauts scooped them up unknowingly in their sample bags. When scientists studied the soils back on Earth, they found these colorful beads scattered everywhere, evidence of a moon once alive with fire. Under the microscope, the beads reveal subtle hues, some orange, some green, some nearly transparent. Apollo 17 astronauts even reported seeing a strange orange soil at the rim of Shorty Crater, the product of ancient volcanic glass. That discovery surprised scientists, who had long thought the moon was geologically dead. The beads proved otherwise. Once, long ago, the moon had erupted violently, leaving behind a quiet legacy in its soil. These glass beads also hold secrets within. Tiny bubbles trapped inside preserve chemical fingerprints of the gases that once filled the moon's interior. By studying them, scientists have learned about the moon's mantle, its composition, its water content, its volcanic history. Some beads even contain traces of hydrogen, suggesting that the moon may hold more water deep inside than once believed. In this way, the beads are not just pretty curiosities. They are archives of geology, carrying messages from a time when the moon was still young and restless. For astronauts, the beads were invisible amid the dust. But for us, their story is extraordinary. Imagine those eruptions, fountains of molten rock arching silently into space, droplets glowing as they cooled, falling back to paint the ground with a rainbow too faint for human eyes. Today, the beads lie buried in the dust, countless and small, yet together they tell of a moon that once pulsed with fire. There is something poetic in their survival. The moon's surface, battered by impacts, frozen in time, still holds these tiny jewels created in fire and cooled in silence. Each bead is a memory of heat, of eruption, of a sky filled with glowing embers. They remind us that the moon was not always a place of stillness. It was once alive with energy, breathing fire into the night. So, when you look at the moon tonight, glowing softly in our sky, remember that beneath its calm face lies a history of flame. Its dust carries the smallest of treasures, glass beads forged by fire, scattered across a gray world. Jewels of a volcanic past lying in silence, waiting for us to see. When we look at the moon today, it feels like a world of silence. Gray dust, still craters, mountains frozen in place. But billions of years ago, the moon was very different. It was not the quiet companion we see now. It was alive with volcanic activity, a restless world where molten rock boiled beneath the crust and fiery fountains erupted into the blackness of space. The moon's story begins with heat. After it formed from the colossal collision that gave birth to it, the moon was still glowing with leftover energy. Its surface may have been a magma ocean, a vast sea of molten rock. As that ocean cooled, lighter minerals floated upward to form the crust, while heavier ones sank deeper. But inside, the heat remained. For hundreds of millions of years, volcanic forces continued to shape the young moon. Volcanoes on the moon were not quite like those on Earth. With no atmosphere, there was no smoke, no rolling clouds of ash, no sound to accompany eruptions. Instead, imagine fountains of glowing lava spraying upward in silence, droplets arcing high in the low gravity, cooling into tiny glass beads before falling back to the surface. These silent fireworks painted the ground with colors unseen orange, green, and clear volcanic glass, still found in the lunar soil today. The most dramatic eruptions filled vast basins with molten rock, creating the Maria, the dark plains we see with the naked eye. When giant asteroids smashed into the moon and carved deep craters, magma surged up through cracks in the crust, flooding the lowlands with basalt. These eruptions were immense, covering areas hundreds of kilometers wide. Over time, they hardened into smooth, dark plains. From Earth, they became the moon's seas, Mare Imbrium, Mare Tranquillitatis, Mare Serenitatis. They are not seas of water, but seas of ancient fire, cooled into stone. The last great volcanic activity on the moon is thought to have ended around 1 billion years ago. Since then, it has grown still, but signs of its fiery past remain everywhere. The Maria themselves are records of lava flows. Reel's long, winding channels trace the paths of collapsed lava tubes. Small domes mark where magma once pushed upward, but cooled before breaking the surface. Even the tiny glass beads scattered in the soil are time capsules of eruptions long gone. For scientists, these features tell a story of transition. The moon began as a hot, molten world, then slowly cooled into the silent, airless sphere we know today. By studying volcanic rocks brought back by Apollo missions, researchers have learned that the moon's interior once contained gases like water vapor, sulfur, and carbon monoxide, evidence of its volcanic nature. These clues reveal not only the moon's past but also the history of planetary evolution itself. There is wonder in imagining it. A moon glowing with lava under a black sky, eruptions painting its face with molten fire, rivers of glowing basalt flowing for miles. No sound, no atmosphere, just the hiss of molten rock cooling against ancient stone. For billions of years, this was the moon's heartbeat fire beneath silence, shaping the face we see today. So when you look at the moon tonight, remember that its calm glow hides a past of flame. Those dark seas are scars of fire. The beads of glass in its dust are droplets of eruption. The ridges and channels are paths of molten stone. The moon was once alive, and though its fire has faded, its memory remains. It is not only a world of silence, it is also a world of fire, written forever into its face. Most nights, the moon glows steadily above us, bathed in sunlight reflected across space. But every so often, its light fades. A slow, creeping shadow begins to move across its face, dimming the bright disk until it turns a coppery red. This is a lunar eclipse, a moment when Earth itself casts its shadow upon the moon. A lunar eclipse happens when the sun, Earth, and moon align in a perfect row, with Earth in the middle. As the moon passes through Earth's shadow, the sunlight that normally illuminates it is blocked. From Earth, it looks as if darkness is slowly eating away at the glowing orb in the sky. The event can last for hours, unfolding in stages from the first nibble of shadow to the full eclipse, and then to the moon's gradual re-emergence into light. But even in full eclipse, the moon does not vanish. Instead, it glows with a deep reddish hue, as though lit by embers. This happens because Earth's atmosphere bends sunlight around the edges of the planet, scattering blue light and letting the red and orange tones pass through. These colors filter into Earth's shadow, painting the moon with the soft glow of every sunrise and sunset happening around the world at that moment. In a way, the eclipsed moon is bathed in the collective light of Earth's horizons. For ancient people, lunar eclipses were awe-inspiring, sometimes frightening. A familiar light suddenly darkened, replaced by a blood-red disk hanging in the night sky. Myths arose, dragons devouring the moon, gods showing anger, omens of change. Yet across cultures, they were also moments of wonder, times when the heavens revealed their hidden alignments. Today, we understand the science behind eclipses, but the feeling of mystery remains. Standing beneath a darkened moon still fills us with quiet awe. Unlike solar eclipses, which can be seen only along a narrow path, lunar eclipses are visible anywhere on Earth where the moon is above the horizon. They unite continents in a shared experience. Millions of eyes looking up at the same shadow, the same reddish glow. In these moments, humanity is bound together under a single celestial event, connected by light and shadow across the globe. For scientists, eclipses offer opportunities as well. By studying the way Earth's atmosphere bends and filters sunlight during an eclipse, researchers can learn about its composition. Similar methods are now used to study distant exoplanets, where the dimming of starlight during eclipses reveals the makeup of alien atmospheres. Our moon, in falling into shadow, teaches us not only about Earth but also about worlds beyond. But beyond the science, a lunar eclipse is also a lesson in perspective. It shows us the dance of three bodies, sun, Earth, moon, aligned in cosmic geometry. It reminds us that shadows, usually small and local, can stretch across space to embrace an entire world. And it demonstrates how even darkness can hold beauty, as the moon glows softly red in the cradle of Earth's shadow. So, when you next witness a lunar eclipse, take a moment to feel its quiet power. Watch as the familiar face of the moon is transformed, dimmed, and reborn. Remember that what you see is Earth's shadow stretching across the heavens, our planet's outline painted against the night. The moon, for a brief time, becomes a mirror not of the sun, but of Earth itself. Most of the time, the moon drifts quietly through the sky, a companion reflecting sunlight in gentle silver. But on rare occasions, it performs one of the most dramatic shows in the heavens. It moves directly in front of the sun, covering its brilliant face and casting a shadow upon Earth. This is a solar eclipse, a fleeting moment when day becomes night, and the ordinary turns into the extraordinary. A solar eclipse happens because of a cosmic coincidence. The sun is about 400 times larger than the moon, but it is also about 400 times farther away. This perfect ratio means that from Earth, the sun and moon appear almost exactly the same size in the sky. And so, when the moon passes directly between Earth and the sun, it can cover the sun's disk with astonishing precision. For a few minutes, the small moon hides the mighty Sunday. There are different kinds of solar eclipses. In a total eclipse, the moon completely blocks the sun's light, revealing the faint corona, the sun's outer atmosphere streaming out in delicate white tendrils. In those moments, stars emerge, animals grow quiet, and the world feels as if it has slipped into twilight. An annular eclipse happens when the moon is a little farther from Earth, appearing slightly smaller than the Sunday. It leaves a glowing ring of fire around its edges. A partial eclipse occurs when the alignment is not exact, and the moon covers only part of the sun's disk. Each type has its own beauty, but the rare total eclipses are the most awe-inspiring. For those who experience it, a total solar eclipse is unforgettable. The light dims as the moon slides across the sun, shadows grow sharper, and the air cools. Then, in a sudden moment, the sun's brilliance vanishes, replaced by a black circle surrounded by a crown of light. People often describe the experience as otherworldly, a humbling reminder of our place in the cosmos. It is a moment that unites science and wonder, knowledge and emotion. Throughout history, solar eclipses have stirred awe and fear. To ancient cultures, the sun's sudden disappearance was alarming, interpreted as omens of disaster or messages from the gods. In China, legends told of dragons devouring the Sunday. In other places, people banged drums or lit fires to scare away the darkness. Over time, as astronomy advanced, humans learned to predict eclipses, turning fear into fascination. Today, they are celebrated as cosmic events that draw travelers across the world to witness their fleeting magic. Eclipses are more than spectacles. They have advanced science in surprising ways. In 1919, a total eclipse provided the first observational proof of Einstein's general theory of relativity. During the eclipse, astronomers measured the bending of starlight around the sun, confirming that gravity could warp space itself. The moon's shadow, falling across Earth, became a laboratory for one of the greatest discoveries of modern physics. And yet, beyond all the science, solar eclipses remain deeply personal experiences. To stand beneath one is to feel the delicate balance of our solar system made visible. The alignment of sun, moon, and Earth becomes something we can see and feel, as daylight itself yields to shadow. It is as if the universe pauses, reminding us of its grandeur and its precision. So, when the moon next crosses the sun, and daylight fades to twilight, take a moment to look up with wonder. Remember the coincidence that makes it possible, the delicate geometry that allows a small moon to hide a giant Sunday. For a few minutes, the familiar sky will transform, and you will witness the cosmic dance revealed in shadow and light. The moon, usually a mirror of the sun, becomes its veil, reminding us that beauty lies not only in light, but also in the moments when light is hidden. And so, as the moon drifts silently across the night sky, It carries both the memory of ancient collisions and the promise of future journeys. Its craters are time capsules, its tides are lullabies, and its glow has been our comfort since the beginning of human memory. The moon reminds us that even in stillness there is motion. Even in silence there are stories. Thank you for joining me tonight on this gentle journey through lunar wonder. If you'd like more calm explorations of science and the cosmos, consider subscribing and sharing this space with others who love quiet discovery. For now, let your eyes grow heavy, let your breath grow deep, and drift into dreams under the same moon that has watched over every generation before us. Good night.